Another important topic in Unit 4 is types of AC filters. What is the AC filters? What are the types of AC filters? What is a DC filters? What is the main aim of filter? We see in this topic. Normally, the filter requirement in HVDC system is necessary because there are more harmonics are present. The harmonics can be easily eliminated by using filter circuits. The name indicates filter that filters the harmonics. Means what is a harmonics? Harmonic is a multiple frequency. Multiple frequency. If third harmonic is frequency is 150 hertz, fifth harmonic is 250 hertz, seventh harmonic is 350 hertz. So the harmonic content having more frequency. So the normally the fundamental frequency is 50 hertz because this harmonic third and fifth and seventh harmonic causes the waveform of basic wave is changes that causes more number of problems. This frequency is eliminated. The dominant frequencies third, fifth, and seventh, and ninth, 11th, and 13th harmonics can be eliminated by using filter circuits. Harmonics are present in both AC side as well as DC side. So, AC side harmonics already we know H is equal to harmonic order H is equal to NP plus or minus 1. In DC side H is equal to NP. We know that formulas. Based on that formulas we can eliminate the frequencies. We can eliminate the harmonics. If you eliminate the frequency, automatically eliminate the harmonics. So normally the filter circuit consists of inductance and capacitance. So inductance causes inductive reactance, that is the XL is equal to 2 pi FL. Capacitive reactance causes XC, that is equal to 1 by 2 pi FC. So the inductance and capacitance combination is nothing but filter circuits. Already I told that the harmonics are present in both AC side as well as DC side. AC side harmonics are filtered by using AC filters. They were used to filter AC current harmonics. They were also used to supply reactive power. In AC filter serves two purposes. First one is it eliminates the harmonics. Second one it supply the reactive power. The two purposes can be using by using AC filters. Normally AC filters are band pass filters, high pass filter, second order filter, C type filter, and the DC filters are DC smoothing reactors with DC filters was used to filter the DC harmonics. Already I told that what is the purpose of DC smoothing reactor. DC smoothing reactor purpose is to eliminate the harmonics, to eliminate the ripples, and also that will use it for protection. The DC smoothing reactor with filter causes more harmonics are eliminated in DC side. The different types of DC filters are single tuned filters, double tuned filters. These are the different filters. So different type of applications, which harmonic content in the system, how to eliminate that harmonics, which filter will be used is a very important phenomenon. On which application, which harmonic, which filter is used to eliminate that harmonic. So the first one is single tuned filter. Single tuned filters are designed to filter out characteristic harmonics of single frequency. Please see that consist of resistance, inductance, and capacitance. So what is the F0? F0 is a resonance condition. The F naught is nothing but whenever the inductive reactance is equal to the capacitive reactance, that is a resonant condition. If you observe the graph, graph is drawn in between impedance versus frequency. And now the frequency increases, how the impedance will be changes. Impedance Z is nothing but, what is the impedance Z? R plus jx, where x is the reactance, that is the inductive reactance or capacitive reactance. So please observe the diagram. Whenever the lower frequencies, the impedance is maximum. Whenever the frequency increases, and whenever the inductive reactance is equal to capacitive reactance, which is called resonant frequency, f naught is the resonant frequency. On that situation, the impedance is minimum. Whenever the inductance reactance xl is equal to xe, z is equal to r. On that condition, z is equal to r, the z gets minimum. So after the resonant frequency, the impedance always increases. Please observe this graph in single tune filter. Single tune filter consists of RLC elements. Double tune filters. The double tune filters are used to filter out two discrete frequencies instead of using two single tune filters. Their main disadvantages are only one inductor is subjected to full line impulsive voltage. Second one, power loss at the fundamental frequency is considerably reduced. There is two purposes. Only one inductor is subject to full line impulse voltage. Second one is power loss at the fundamental frequency is considerably reduced. So please observe the double tune filter. In the double tune filter also a elements are LC, but there are more number of elements. In single tune filter we have one or LC elements. In double tune filters there are three resistances, two inductances, two capacitances, namely R1, R2, R3 resistances, L1, L2 inductances, C1, C2 capacitances. Please observe the diagram of double tune filter. It eliminates two frequencies. In previously, single tune filter eliminated single frequency, single harmonic. Double tune filter eliminates two harmonics, mainly dominant harmonics. Please observe the diagram. Same impedance versus frequencies. There is a two resonant conditions. Resonant F01, F02. The impedance will be decreases under resonant condition and then increases under. We have another resonant condition in this double tune filter circuit. Second order high pass filter. The second order high pass filter are designed to filter out higher harmonics. Please see, high pass filter having three elements R and L are in parallel, C is in series. Please observe the diagram, impedance versus frequency graph. So whenever the impedance frequency is minimum, impedance is maximum. Whenever the frequency increases, the impedance will be reduces. So in this second order high pass filter, there is a resistance line. The impedance must be increasing order within the limits of resistance. Please observe. So this part is Z minimum, impedance versus frequency graph in second order high pass filter. High pass C type filter. The losses at the fundamental frequency can be reduced by using a C-type filter where capacitor C2 is in series with inductor L, which provides a low impedance path to the fundamental component of current. Please observe the high-pass C-type filter. Two capacitance C1, C2, one inductor and resistance. The graph will be similar to the previous one, which is that one. Second order high pass filter, high pass C type filter having same graph. The losses at the fundamental frequency can be reduced by using C type filter where the capacitor C2 in series with the inductor L, which provides a low impedance path to the fundamental component of current. Here we have two capacitances. This is high pass C type filter. A converter system with 12 pulse converter has double tuned or two single tuned filter banks to filter out 11th and 13th harmonics, and a high pass filter bank to filter the rest of harmonics. This is a very important point. In 12 pulse converter, 11th and 13th harmonics can be eliminated by two single tune filter or double tune filter. We using any one, two single or one double, and high pass filter to bank out to filter the rest of harmonics. Sometimes a third harmonic filter may be used to filter the non-characteristic harmonic of the third order, particularly with weak AC system where some voltage imbalance is expected. All filter branches appear capacitive at fundamental frequency and supply reactive power. Design of single tuned filter. The impedance Z of the single tuned filter at the harmonic order H is given by R plus J H omega L minus H omega C, where omega is the fundamental frequency which can vary with the power system operating condition. A tuned filter is designed to filter single harmonic of order HR. If HR omega is equal to omega R, then impedance Z is equal to R. The formula is X naught by Q and is minimum. Since omega is variable and there could be errors in the tuning, omega are not equal to H or omega n, where omega n is the nominal rated frequency. It is necessary to compute the impedance of the tuned filter as a function of the detuning parameter delta defined by this one.